everybody, Dr. Urban here. I don't know why this thing is vibrating a little bit. Okay, let's look at momentum. This is our second to last chapter, and this, I am going to guarantee you, is one of the most fun ones we do all year. So with momentum, well, let's start at the beginning. When you say kick a soccer ball or hit a baseball or frankly just take one step, what's happening is the part of you that's moving, so let's take the example of taking a step. Your foot is moving, and then it hits the ground and it stops moving. And so you feel that impact from the floor against your foot. How does all of that work? So if you have my chapter 9 slides, I am going to give you sort of a brief, about a 10-minute overview of how to look at momentum and how to do these types of problems. So we're going to talk about a new letter. It's J. It's an impulse. Okay, this is the average, because we're in the algebra-based course, the average force times a little piece of time. What am I talking about? Well, impulse is the force during an impact. This could be your foot touching the ground. This is a baseball hitting a bat. This is you bouncing something and catching it, like when a basketball hits the ground. There's an impulse. It's a force that's generally, make a little note, big force applied over a tiny, and I mean tiny, piece of time. Okay, this is time. This is the time of the impact. Okay, so all we're doing is talking about how long it takes when, say, here's a ball, okay, and it's falling. It has an initial velocity toward the ground, okay, and this ball, we'll call it mass 1. It's falling, and then later on, it hits the ground right here. I'll try to make it look like it kind of mushed against the ground. There we go, it impacted with the ground right there, and then it bounced back up. So these are 3 different scenarios. Now the ball has bounced back up. I'll call it mass 1, okay? And its final velocity is like this. So real quick, what's the sign of that initial velocity? It's going toward the ground. The sign here is going to be negative. Now it's bouncing up. I have a velocity vector in the y direction. That is going to be a positive final velocity. But what is happening right here? Well, right here, the ball is hitting the floor, but Newton's third law says what's happening from the floor. The floor is imparting a force, okay, right here, times the time that it hits. So what's happening is that this is where the impulse is. So the direction of the force and the impulse are opposite where the ball is impacting the ground. So the impulse is the force of impact, force during impact, times the time of contact. Now, this is like a basketball. You can see that's a really short period of time. Or a baseball coming in and hitting a bat, that is such a short period of time. But we have to take into account everything else in the picture. The ball fell, then there was the impact, and then the ball bounced back up. I need to take into account these 2 parts of the picture I drew. So what I call that is a change in, new letter, momentum. Change in momentum. Dr. Urban, you haven't told us what momentum is yet. Well, hold on, give me a second. Momentum is the object's mass times its velocity. Velocity is a vector quantity, so momentum is a vector quantity. So right now, what is this momentum? It's mass 1 times this velocity, which is negative, so that'd be negative momentum headed downward. And then there's impact and an impulse right here. And then I have that same mass going a new positive velocity. So a change must be final minus initial. So let's rewrite this. The impulse is the average force times the very small piece of time equals the change in momentum. Let's be more clear. It equals final momentum minus initial momentum, which equals mass 1 V1 final. Let's say there are 2, we'll just do one object right now, minus mass 1 V1 initial. Okay, so again, because final minus initial, okay, and then so mass 1's V1 final, mass 1's I made that more complicated than it needed to be because I only have one mass. So mass 1 V final minus mass 1 V initial. But what if I had a whole bunch of things? Okay, so this is your general problem. And so this is it for some of the problems. Some of the problems will say a ball is doing such and such, falling toward the earth with given velocity. It's in contact with the earth for this period of time, and then it bounces back. So you're going to need to deal with the average force and the change in momentum. So these problems are relatively straightforward. We could make this more complicated using 3 quick scenarios. So draw a little line here, and I'll do this on the board for you, of course, but I have mass, let's call this guy A, and he's sitting right next to mass B, okay? And then on this line, we'll just start with this first scenario. Actually, hold on, just a minute. Let's back that up. Okay, I have mass A, and it's moving this way. Mass B is moving this way. Then they hit. There's some kind of contact. And then they're going to be moving at the end. So maybe A recoils and goes back that way, and B bounces off and recoils and goes back this way. That's one scenario. They were moving in some way. Now, again, I've drawn it like where B is big and A is little. I've drawn it where they hit and then they bounce off, but they could. A could be going so fast that when they hit, they both go this way. They could hit and come to a stop, but these are the general scenarios you're going to ask yourself. Do they hit and do they bounce off? This would be elastic collision. But what if the only other real scenario here is if they move toward each other, and when they impact, if they stick together. Okay, draw my impact here. What if they stick together? What if A is really moving, okay, and A and B stick together, and then they both are moving at a new final velocity this way? So what I'm going to do is I'm going to figure out what my final momentum is, each mass and its final velocity, and put that on one side of the equation. So I'm going, inelastic. That means they stick together. Okay, these are my 2 scenarios. So what would I be doing? I'm probably going to be looking at the final momentum, having that equal to the initial momentum. Basically, the change in momentum in this case is 0. And if I have these 2 scenarios, and my situation is conserved. I have no loss of energy in my system, conserved. Okay, so my final must be equal to my initial. So all final momenta must be equal to all initial. So you grab each piece. So this is the V initial here for these guys. So that's V initial, V initial. And then at the end, this is the V final. So I'd take mass A, write that over here, times its final velocity, watch the sign. Mass B, whatever its mass is, times its velocity, watch the sign. And then go back, get my initial scenario, put that here, and then solve. That's how this looks, okay? So do I have enough space? Yeah, so I'd write like mass A, velocity A final, plus mass B, velocity B final, and however many there are, is equal to mass A, velocity A initial, plus mass B, velocity B initial, and so on. And that's how elastic collisions work. Let's see if I have a red pen, because I need to write in big letters, watch your signs. And all of these, this is where you go wrong, because it's simple. You can multiply mass times velocity, mass times velocity, mass times velocity, but you're going to need to reorganize this. What if I want final velocity or initial velocity of B, final velocity of A? You're going to set this equation up, get everything onto one side of the equation. So watch those signs when you do that algebra. Are they positive or negative velocities? Question mark, question mark. Okay, same deal over here. I am going to have a change in momentum that is 0 for this type of problem. Okay, and so my final momentum must equal my initial momentum. For these inelastic or stick-togethers. I think one of the homework problems is a bird flying this way and a bug flying this way. The bird eats the bug. I think there's one where there's a train car moving and then a whole bunch of materials dumped into the train car. So it's an adding together of those two masses. Okay, so what is my final momentum scenario? Well, they're stuck together. So you have to say mass 1 or mass A plus mass B. All of the masses are stuck together. So they have one final velocity because they are all stuck together. The bird ate the bug, or all the train cars stuck together, or whatever. Add all the masses up times one final velocity. But the initial scenario is similar to this one. I have mass A has velocity A initial, mass B has its velocity B initial, and so on. And again, all you have to do is watch your signs. Okay, so this thing was going, A was going this way, B was going this way, then they get stuck together. It's two sports, football players, then they tackle, but B was going so fast that they tackle and they're actually still holding on to each other, and the player B pushes player A back. So their final velocity would be the combined mass is going that new velocity. But in the beginning of the problem, they were running towards each other, so that you had individual velocities at the beginning. So again, set it up. What is happening? I have two things. They have initial velocities, they hit, and now they're moving apart. And what's my whole final scenario? What's my whole initial scenario? Do the problem. Same here. I have two things, they're apart, now they're stuck together. All the final information on one side, the initial information on the other side, do the algebra. Watch the signs. And then there's one problem in this type of problem that's sort of a shortcut. So it's where initially they're not moving. There's no initial velocity, so it's basically like A and B are here. There's an example in the notes. There are two people on the ice, and then they push apart. But basically, it's an explosion. So V initial for all is 0. So there's no initial momentum. But then there is an explosion or something, or they push apart, and later on, let's say A is going this way with his V velocity of A final, and B is going this way with velocity B final. And so if there's nothing in the beginning, so final momentum equals 0, then you put, what is this? So this would be mass A velocity A final equals mass B velocity B final. But you just need to watch your signs. And that's it. So momentum is really fun. Momentum is a quantity that the object has. It has a mass, and it's moving at a velocity. So at any time, what's your momentum? Are you sitting still? So you have your mass, but you're sitting still watching this video. So you have no momentum. If you were to start walking around your room, you now have a momentum. You have your mass times your velocity. So right now, what is the mass of this object? What is the velocity of this object? What is the mass of this one? What's the velocity of this one? Okay, got that. Then they hit each other, and then what happens? Do they bounce off? Is it like you accidentally rear end a car, but you kind of bump like that? Do you rear end a car, your car gets stuck together, and you both slide this way? So what does it look like at the beginning? What is the collision? And what is the end scenario? And again, there's no rotation in this right now. So this is a linear momentum, and hopefully this will get you started.